This video will go over two different things. The first thing that we're going to go through is dividing monomials. So when you divide a monomial, you want to look at the exponents and you're going to subtract your exponent. Now, depending on which exponent is greater, it's going to determine where you put your base, either on the numerator or the denominator. So if you have exponents m and n, if m is greater than n, then you're going to subtract m minus n with your base on the numerator. But if your m is less than n, then your base will go on the denominator, and you're going to have 1 over that base. And you're going to subtract n minus m. So you want to do the greater exponent minus the less exponent so that you won't have a negative. So for example, if we look at number 1, and we have x to the 11th divided by x to the 3rd. So really what this is doing, and the reason why you subtract, is if you have x 11 times, on the top and x 3 times on the bottom, the reason why you subtract the exponents is because you can get rid of the same thing that's on the top and the bottom. So this is saying we're deleting 3 x's and we're left with 8. So that's why you can subtract the exponents here. And in this case, 11 is greater than 3. So our base of x is going to be on the numerator. X to the 8th is our answer. Now, if the opposite were to occur, and I'll draw out this scenario as well. Oh, this is x to the 3 on the top, and then x to the 11th on the bottom. This is the same scenario, but flipped. We have x to the 3rd on top and x to the 11th on the bottom. So again, we can clear out 3 x's. And here we're just left with 1 on top. 1 over x to the 8 times. Now, if you were to do the first rule, and you could see that this is a negative sign, you'll have a negative exponent. A negative exponent means to put it in the denominator. So this and this are equivalent. But this is the proper way to write your final answer, as you can see by the photo, the picture. So the reason why you have this rule, if your m is less than n, is so that you can have a positive exponent in the denominator. Okay, so let's continue. Now this one, we have a parentheses, so you want to treat this whole thing as 1. Okay, so really this is equal to 15x minus y to the 1st power over 15x minus y to the 13th power. Now again, just like if this were x, you would write this out 1 time and this out 13 times, or you can use the rule. So this exponent is greater than this one. So that means our base of 15x minus y is going to be on the denominator. And we're going to do 13 minus 1. Okay. So that means the final answer here will be 1 over 15x minus y to the 12th. Now, number 4 has 2 variables, but you still use the same rules. So let's break this up separately. If we look at the x variable, we have x to the 4th and x to the 6th. 6 is greater than 4, so our base of x will go on the denominator. And then if we look at y, the same thing applies. 7 is greater than 4, So we'll have y to the 3. So that means our final, you have to multiply the 2 just like you'd have here, will be 1 over x squared y cubed. Okay. Now this one has a constant in it. So whenever you have constants, you want to reduce them as much as you can, and then treat the variables as we've been doing before. So the first thing you want to do is see, does 9 go into 45, which it does. And if 9 was on the numerator and 45 was on the denominator, then you can still reduce that to 1/5. So just be cautious of that you also reduce your constants. Okay, so now let's look at the x variable. We have 15 on top, 20 on bottom. So that means our x should be on the denominator. 20 minus 15 to get 1 over x to the 5th. Now for y, 12 is greater than 4. So y should be on the numerator to get y to the 8. So then our final answer, once you combine everything, is going to be 5 times. Now our y is on the numerator, so y to the 8. But x is on the denominator, so divided by x to the 5th is our final answer. Okay, so now let's switch gears a little bit. And let's go to what if you have 0 in your exponent? How do you simplify these? Now, the thing about 0 is anything to the power of 0. So anything raised to 0 is 1. Because you can only raise something to the 0 one time. Okay. So anything raised to the 0 power is 1. Okay. So this has a parentheses, and 0 should be distributed to both the 2 and the x. So when we rewrite this, it should be 2 to the 0 times x to the 0. So that means we're going to have 1 times 1 in this scenario. Because both of these, anything raised to the power of 0 is 1. So 1 times 1 is 1. Now this is going to be different than this one because 2 is not raised to the power of 0, but x is. So this is really 2 times 1 to get 2. Now the same scenario happens here as the first one, except we have 2 parentheses here. So what you want to do is take all of this in the parentheses and raise it to 0. So 12 raised to the power of 0 and x raised to the power of 0 are both 1. 4 raised to the power of 0 and x raised to the power of 0 are both 1 as well. So the final answer for this is 1 minus 1, which is 0. So you have to be careful with parentheses because that will determine what gets the power of 0. So that is different than number 9 because 12 and 4 aren't raised to the power of 0. But the x's are. So you have 12 times 1 here minus 4 times 1 here. So this answer is 8. So look at the difference between the two and understand why parentheses make a huge difference. Because here, this is saying everything in the parentheses are raised to the power of 0. And this only has x to the power of 0. So you're going to multiply 4 times 1 and 12 times 1. So don't confuse the two. And for our last question, we have 2 plus x raised to the power of 0. So we just have 2 plus 1 to get 3. Okay, so this is where I will stop with these two concepts. This was just a quick lesson to show 0 as an exponent and to go over dividing monomials. If you have any questions, please let me know. Thank you.